this is example 2b, another situation of a word problem. With systems of inequalities. All right, here we go. Here's our situation. Tickets to a concert. Cost $70 each. Or $20 with a student discount. Ticket sales must exceed $500,000 for the group to perform. If 20,000 seats are available, how many of each type must be sold? So this problem, we have some pretty big numbers, pretty big quantities that we're working with, and that's okay. We'll work with it. So tickets cost $70 each or $20 with a student discount. Both of these quantities are related to cost. We also have this quantity related to cost, the $500,000. Ticket sales must exceed that quantity. And we have 20,000 seats that are available. How many of each type must be sold? Well, let's start off by assigning our variables. I'm going to use X to be our number of regular seats, the number of regular tickets that are sold, and Y is the number of student seats sold. Okay. So first thing, or I guess the next first thing, is to start writing our inequalities. My first inequality, I'm going to write related to the cost. So $70 each for regular tickets. So 70x would tell us how much money is coming from the sale of those regular tickets. And $20 for our student discount would 20y would tell us the amount of money that's brought in by selling those student seats. So 70x plus 20y must exceed, so it has to be greater than $500,000. And let's think for a second. Okay, ticket sales must exceed $500,000 for the group to perform. That must exceed makes it look like, makes it sound like it has to be more than 500,000. If you think of, really it probably is okay if they brought in exactly $500,000. Totally be okay if you put the equal to sign underneath this also for that reasoning. But since it says exceed, I'm going to leave it with just greater than. And then we have 20,000 seats are available. So together, X plus Y, well, we can't sell more than 20,000, but there are 20,000 seats available. It's okay if it equals 20,000. This is my system of inequalities that we are working with here. All right, let's get Y by itself in both of our inequalities. So first one here, 70x plus 20y. I should keep using my green pen to stick with the color thing here. 70x plus 20y is greater than 500,000. Start off by subtracting 70x from each side. and then I'm going to divide both sides by 20. So this would be 25,000 minus 3.5x. And I'm actually going to leave that as, instead of 3.5, 70 over 20 is 7 over 2x, because this will make it a little bit easier to see rise over run. And then my second inequality, let's get y by itself, subtract x from both sides. Y is less than or equal to 20,000 minus x. All right, so again, we have some pretty big numbers that we are working with here, but that's okay. We'll just have to adjust our scale on our x and y axes accordingly. And like that last problem, example 1a, I'm not going to go negative to the left really, or down below, because we're not going to have a negative number of regular tickets. We can't have a negative number of student tickets sold. So I'm going to label my axes here too. X was our number of regular seats. Y is the number of student seats. Number of student tickets. All right, and on our y-axis, we're going to have to go all the way up to 500, or sorry, all the way up to 25,000. Let's go. I don't want to go by too crazy of a scale here. Okay, to finish this off, I started off trying to have each mark be 5,000, and then I decided against it. So now I go up to, and this is 5,000, up to more is 10,000, 15,000, 20,000, 25,000. So there's a little bit of messiness going on here, but we want to be consistent with our x-axis, especially because as we count out slope, if we weren't consistent, then our inequality is going to look totally wrong. So y is greater than or equal to 25,000 minus 7 half x. Our y-intercept is 25,000, and our slope is negative 7 over 2. And although it doesn't have any meaning for our problem, going into our negative y values here, it still helps to have another point on our coordinate grid. Greater than means I'm going to use a dotted line here. Because it can't equal, even though, like I said, if you had put that equal to option, I wouldn't really argue with you in this problem. And then our second inequality, y is less than or equal to 20,000 minus x. 20,000 is our y-intercept. Negative 1 is my slope. And solid here. Okay, as far as shading goes, less than or equal to, my solution is below that line. And then for my green inequality, the 25,000 minus 7 halves x is anything above. All right. So my double shaded region is right here. And as far as my ticket sales go, we could have, and I'll, similar to that last one, just kind of list out a few here, because there are a lot of other numbers in between here. Like, we could have 10,001 tickets, 10,001 regular tickets, and 5,602 student tickets. So there are a lot of other combinations that we don't see, but here are a couple. We could have 10,000 regular tickets and 7,550 students. We could have 15,000 regular and 2,500 students. Okay. And again, there are a lot of other more other combinations that we can't see, but here are just a couple of our examples that would work.